Welcome back, nerds. Today we're going to be getting an L298N motor driver breakout board to spin some motors. I'll introduce the board, then we'll wire it up and finally program it. So the L298N is a fantastic little board that can control up to 2 DC motors proportionally and independently. It's just a dual H bridge, so there's nothing fancy going on under the hood, but it can control up to 35 volts with limited amps, which makes it pretty powerful. If you're using it to provide power to 2 different motors, it's going to eat up 6 pins of your Arduino, which is kind of a huge con to this thing. But often in small projects, the simplicity of the L298N far outweighs the cost of those 6 pins. Let's look to the wiring diagram. Looking to this very legitimate wiring diagram, we can see 2 pairs of 3 pins that control the outputs. They are located here and here, which control the outputs there and there, respectively. Breaking it down further, we've got the enable pin, which has to be routed to a PWM port, and we have the direction pins that have to be routed to basically any digital output. Here's how I'm going to wire mine. The enable is going to go to digital pin 6 of the nano, in 4 is going to go to digital 7, in 3 is going to go to digital 8. Then I'm going to have out 3 go to the negative terminal of my motor, out 4 go to the positive, then the battery or your voltage source gets wired to the input, which is here, then the ground goes to ground, and very important note, you have to tie the ground of your system that is feeding the L298N to your nano, or else you won't have proper communication. Let's look to how it actually looks. Alright, here I've got the nano, I've got the L298N breakout board wired to a motor and my power supply, as well as a PWM cable, and then I've got another cable which will connect the ground of the L298N to the nano. Why I like PWM cables is because it's got the 3 pins that fit right on the enable and direction pins and then go into the Arduino. So I've got the signal here, which is in orange, going right to digital 6 because that's what I said on the wiring diagram. And then we've got orange here, which will go to the positive terminal of my power supply. Then I'm going to get my 2 wires here that'll be grounds connected to the ground of the power supply, and finally to the ground of the nano. Ugh. Sick. And now we're ready to go. I wrote a small library for using the L298N with Arduinos, and I uploaded it to GitHub, so we'll be using that for the majority of this programming tutorial. You're going to want to navigate to the link in the description, download the archive as a zip, and then import it into the Arduino IDE. How we get to the example file is by going to File, Examples, L298N _LE, and then Simple Motor 1, which I've already got up on the screen here. I'll detail some of the functions now. Firstly, we instantiate an L298N object, which is set about by L298N _LE, and we pass it the PWM pin, which we detailed was 6, and then the direction pins, which are 7 and 8. Then to use the motor, we go into our loop function, and we can see that it's motor, which is our name of our object, motor.drive, and then in the parentheses go a value from 0 to 255, 0 being full backward, 255 being full forward, and 127 being no power. What we'll do with this function is we'll have it sweep through all of the values 0 to 255 and see the motion that outputs. So let's upload the sketch and check what's happening. Alright, there goes the power. Oh, check this. Forward and backward motion. Very cool. That should get you rolling, if you catch my drift. Because, you know, motors for wheels. Get it? There are a few more methods that are helpful if you end up using this library, which would be in our setup function. We can use the method invert to flip the direction that's normal to the motor. And we can also set the dead zone. So thanks for tuning in, and I hope this helps you out. Deuces.